Now, how we prepare? We use one of the important ingredient in the preparation of the electronic circuit on the printed substrate. On the substrate, so how we print? We print we print by using the ink. So, ink is very important for development of any device on the substrate. So, in the printable devices, we use the ink as well as we use the structure as well as we use the substrate. So, first we discuss the printable ink. What type of printable ink we use and how many types of printable inks are there, and what are the parameters we have to keep in mind to define the ink so that we can prepare a efficient device for the further application. So, our printable ink have specific rheological properties and can be divided into three main categories on the basis of the devices we require, that are the conductor, semiconductor and the dielectric materials. And the deposition techniques for patterning these colloidal ink solution enables textures with the desired thickness and resolution. In the inkjet printing, in the screening printing, in the groove printing, in any type of printing, we just use the ink, and that ink we use on the basis of the structure we are preparing and what the thickness of the device, what is the resolution of device. On the basis of that ink has been decided. Each technique requires the proper tuning of the set of the different ink parameters. In the different ink parameters, what parameters are important whenever we decide the ink are the viscosity, surface tension, conductivity and the compatibility with the solvent, and which material compatibility of the solvents and the compatibility with the substrate, because we are printing on the substrate. So, the ink should be like that it is absorbed on the substrate and it will just prepare a desirable devices. When developing the ink for printed electronic devices, several key parameters must be considered to ensure the performance, capabilities and the stability. These parameters can be characterized into the physical, chemical, electrical and processing properties. If we talk about the physical properties, in the physical properties we should keep in the mind the viscosity, which determines the ink flow and printability, which typically must be 1 to 1000 depending on the printing method we are using. Second is the surface tension in the physical properties, which affects the droplet formation and wetting behavior on the substrates. Means surface tension we require that how we can prepare a device and what is a wetting behavior of the ink so that it will not spread on the substrate. So, this will affect the droplet formation of the ink. So, the ideal range must be 25 to 50 millinewton per meter. Another physical property is the density, which is also the important point, which influences the deposition and the film thickness, and that must be of the range of the 1 to 3 gram per centimeter cube. So, this is the physical property. Next is the particle size distribution, and this particle size distribution which is important because which is required for the resolution of the device, of the printed device. So, particle size distribution which affects the resolution, conductivity and clogging in the ink printing, means particle size should be of the range of the which must be greater than 100 nanometer for the nanoparticle inks, because we are preparing the nano devices. So, the clogging in the ink printing should not be there. So, we just keep in the mind the particle size distribution of the ink. Next is the drying and curing rate, which ensures the efficient processing and the adhesion on the substrate. Another is the chemical properties, in which we take the solvent type. Means we are having a powder form, if then how this powder form can be dissolve in the solvent. So, this is the very important point that will define the solvent type. Means that type of solvent we use in which the ink can be dissolved, and that will be used further for the printing purpose. So, the solvent time which impacts the drying rate, adhesion and the compatibility, it may be dissolved in the water, in any solvent, or it may be UV curable. Sometimes we prepare, draw a cracked or not the proper structure on the substrate, so it should be curable. So, it should be removed through the UV light. So, solvent type in which the ink can be dissolved. It may be water, it may be solvent, it may be other. Another chemical properties is the binder and additives. Binder and additives used just to fix the structure on the substrates. So, keeping in mind the substrate and keeping in mind the ink, so binder will be used accordingly, which enhance the adhesion, flexibility and dispersion stability for the device. Another chemical properties are stability and shelf life. Then we are having the prevents the agglomeration and the phase separation over the time. Another parameter is the pH and ionic strength, which is important for the ink formulation, that define the stability and the interaction with the substrate. That will be the important part in the chemical properties. Another properties are the electrical properties. As we are preparing the electronic devices, so the electrical properties is the most important whenever we just prepare the electronic devices. So, in which we just take the conductivity or the resistivity, which determines the efficiency in the circuit application. It means if we having the low resistivity for the conductive ink, high for the insulating ink. So, we keep in the mind the conductivity or the resistivity. As low resistivity we use for the conductive ink and high conductivity we use for the insulating ink. So, these are the efficiency in the circuit application. So, resistivity we are taking, and if we talk about the conductivity, it will be the opposite in that sense. Next parameter is the dielectric constant, which is the key for insulating ink used in the capacitors and the transistors. So, dielectric constant is another parameter whenever we just take the ink for the circuit design. Another is the charge carrier mobility, that is important for the semiconductor ink in the thin film transistor. So, whenever we use a semiconductor ink, now further we will discuss the types of the ink and their uses and their parameters, how we choose. So, if we take the charge carrier mobility, then we keep the semiconductor ink in the mind for the preparation of the thin film transistors and the other electronic devices. The fourth parameter we keep in the mind is the processing and the compatibility. Means we take the ink so that it must be the substrate adhesion. So, it means ensure the durability on the material like plastic, glass, paper or textile. Basically, these are the substrates in which we use the ink. Printability must work efficiently with the different printing techniques like inkjet, screening printing and aerogel printing. So, and another parameter is the thermal stability. Sometimes we use the devices in the different temperature. So, whenever we use the ink, we keep in the mind the thermal stability that prevents the degradation at the operating temperature. Moreover, the device also heat up whenever we are just doing the work. So, the thermal stability is one of the parameter just to decide the ink. Another which is very important is the environmental safety. That must compliance with the regulation RoHS and RECAH and preference for the eco-friendly ink. Nowadays, we are preparing such type of ink which is eco-friendly and which is low cost and which produce the different electronic devices on the paper as well as the PET sheet as well as another substrate, flexible substrate. So, These are the parameters which we have to keep in mind just to decide the ink which we are using. Similarly, the substrate is printing electronics is crucial as it affects the adhesion, flexibility, conductivity and overall device performance. So, these substrates we will discuss in the further lecture, but the ink we will use must be compatible with these substrates. So, we now define the types of ink. We are having a various type of ink, as we discussed that we have a conductive, we have a semiconductor ink, we have a insulating ink, we have a dielectric ink and many more inks, but some of the inks we will discuss in the detail which are very important. So, if we talk about the conductive ink, first we discuss the conductive ink. This conductive ink are the main building block of the printing electronic devices, as you are seeing, and it provides a fundamental device structure, integrated circuit which is interconnected. So, conductive ink offer the metal, nanoparticle and microparticle ink for various type of the printing techniques, in which we are having a silver ink, that is a AG ink with the good physical properties and electrical conductivity. Physical properties in which we have discussed already, that it must be have a good surface tension and it has a good density, and these parameters we keep in mind. So, conductive ink, first is the silver ink, second is the gold ink. We are having the platinum, copper and the nickel ink preferred for the electrochemical sensor, batteries and the fuel cell. Means these ink we use for the preparation of the nano devices, either it will be the sensor, batteries or the fuel cell for the a very small thickness or moreover a small device that will be further used for the further devices, as you have seen in your mobiles that we are having the structures which is prepared through the printing technology, and you can see a very small devices are attached with the interconnected printed wires. So, these, and you will just see that is a gold plated, sometime we use a different type of the metals we use. So, we use the conductive ink like silver, gold, platinum, copper, nickel and so on. And flexible and biocompatible conducting polymers ink essential for the bioelectronics, means we are just use for the diagnose purposes and moreover for the injecting in the body. So, we use the bioelectronic ink which must be flexible and biocompatible conducting polymers. Well characterized carbon nanomaterials ink also having a very large surface area and having a low defect, having a high chemical stability. It is having a mechanical flexible, attractive for the electrode materials in the printed batteries. So, superconductors, we use this carbon nanomaterials for the preparation of the batteries, supercapacitor, scratchable bioelectronics and the wearable sensors also. Means sometime we are having the printed ink for the electronic devices are essential for manufacturing the flexible, lightweight and even bendable electronics. Flexible means we are having the bendable electronics. So, we have a printed circuit board, we can do it on the PCB, we can do it on the organic light imaging diode we use for the sensors and even wearable electronics. Here are some of the key type of the inks used for the electronic devices. These inks are designed to conduct electricity, making them crucial for creating circuits and interconnection between the circuit and the other electronic components. This means this ink, that ink we have defined, that is a conductive ink used to just connect the different devices, and these devices are connected through this conductive ink. And the silver based ink, these are the most commonly used conductive ink primarily due to the excellent electrical conductivity of the silver. Silver is a electrical conductive material, so it is used, but it is expensive, and moreover the another problem in this ink is that it is oxidized very soon. Sometimes we use the copper based inks, so less expensive than the silver, and moreover the copper based inks are increasingly used for printing electronics, so they can be prone to the oxidation. Similarly, the problem is there, but next is a carbon based ink, that is a conductive ink. These inks are generally used for the application where the conductivity requirement are low. So, carbon nanotubes ink or the graphene based ink, that is the carbon family ink, mainly characterized in the basic form. So, now we are having the types of conductive ink, in which we are having the metal based ink and the carbon based ink. Conductive material in the metal base, as you are seeing the difference between the various type of inks. Conductive ink, these are the conductive ink where we are having a metal based ink, we have a carbon based ink, we have a polymer based, and next is hybrid base. So, metal based ink having the conductive material like silver, copper, gold, aluminum. Moreover, having the advantages, which is having a high conductivity, and these are highly stable ink. It is expensive, as the cost of the gold, cost of the silver, copper are more, and there is a problem of oxidation is also in the metal based ink. Application, we can prepare the antenna, we can prepare the flexible circuits, we can prepare the RFID. Next is the carbon based ink. You can see there is a carbon clusters, there is a carbon family in which we can have the ink like graphene, we have the carbon nanotube, that is the CNT, and carbon black we can use for the conductive ink. And if you compare with the metal based ink, it is a flexible, it is having a low cost, it is a stable. Moreover, challenges are there like lower conductivity than the metal. Wearable devices we can prepare by using this, we can use for the sensors, and stretchable devices, electronic devices we can prepare like the carbon. We can use the carbon based ink on the paper, on the cloths, on the or we can flexible for the flexible substrate. Another is the polymer based conductive ink, that is the PE dot, PSS, polyaniline and polypyrrole. Means we are having the different type of the conductive material for the polymer based conductive ink. It is transparent as it is a polymer, so we are having the advantage that it is a transparent, it is a flexible. Again, it is having a low conductivity, and it is having a low conductivity. Moreover, we are having the sensitive to the humidity, so sometimes it will not give the proper result. So, it is a transparent electrodes and touch screens we can prepare by using this, because it is transparent. So, the touch screen we can prepare, and transparent electrode we can prepare by using this ink. Another is the hybrid ink. That ink is the when we use a metal plus carbon plus metal plus polymer as the requirement. So, it is a balanced conductivity, and it is a flexible, and it is a complex, having the complex formulation. Moreover, it is a stretchable circuit we can prepare. Moreover, we can prepare the biomedical application by using the hybrid ink. It should be environmental friendly. What are the key parameters for the conductive ink, which is very important? Conductive or resistivity, it determines the circuit efficiency. If we talk about it, then we can have the typical value for the conductivity 10 to the minus 5 to 10 to the minus 4. It is for the silver based ink. Omega centimeter, and viscosity is it affects the printability, as we have seen that viscosity is defined the wetness, and viscosity means the thickness, how much the devices we are preparing with the particular thickness, that affects the printability, that is a 1 to 100, 1 to 1000, and varies for the printing methods. Surface tension, which influence the adhesion and the wetting. Surface tension must be 25 to 50 in case of the conductive ink. Curing temperature and impacts compatibility with a flexible substrate, which is 82 to 250 degrees centigrade, which is low for the plastic, high for the ceramic. And moreover, adhesion to the substrate which prevents the which will prevent the delamination, that is will be the that is a strong adhesion to PET, PIN paper and extra. Another is a printing method and compatibility with this conductive ink. So, if we take the inkjet printing, then we use the different silver, copper, graphene, PE dot, PSN. It is having the high precision and low waste. Moreover, common applications as we already discussed, that RFID sensors and fine circuits we can prepare. Similarly, we can use this ink for the printing purpose also, screening purpose also. So, silver, carbon and copper are used for the screening, and the thick layers cost effective, we can prepare flexible circuit and antennas we can prepare by using this. Flexography we can use for the printing, that is the silver, that is the silver, graphene and PE dot, which is having the high speed from roll to roll, that is a smart packaging, that will be used for the smart packaging as well as the labels. And aerogel printing, we are having a silver carbon nanotube, 3D and fine patterning, we can get it from this biomedical and aerospace circuits we can design by using this. How we choose the right conductive ink? We choose the right conductive ink by having high conductivity and its performance. Like silver based ink we can choose if we take the high conductivity. For cost effective solution, we can use the copper based ink which requires the antioxidation treatment. Another is for flexible and stretchable electronics, we can use the carbon nanotubes or the graphene ink. For the transparent conductors, we use a PE dot, that must be the polymer, or the PSS or the hybrid ink. So, we can use these ink for the different purposes. Another ink is the semiconductor ink, which is this ink are the core component of the printing electronic devices, and it is largely determine the performance of the final devices. So, we offer a broad selection of both the conventional organic and inorganic inks and the next generation two-dimensional material ink. We will discuss further about the semiconductor inks in the next lecture. Thank you very much.